we are continuing our discussion around the common questions of lighting and the NEC. We had 25. We got up, I think we got through 8 questions plus an introduction. And the introduction, I just tried to make things a little bit more generic. So hopefully, to give us some background. So we are going to go straight to question number 9 and continue our discussion. Please remember to use the chat on YouTube and in Facebook land. Same way, please use the chat there as well for any questions. We've got a good. We'll just continue this up, and again, this will be available at any time. All right. Question number 9 is NEC 240.83 includes requirements for circuit breakers used to switch fluorescent and HID lighting circuits. Does the NEC, other codes, or engineering principles require the same concern for incandescent or LED lighting circuits? If you look at Part 7 in the 2020 code, I'm just going to grab my book. Ouch, sorry about that. So we're in Part 7 in 240.83. So Article 240. And the reason I'm opening my book, I just want to make sure that I have the language hasn't changed with the 2020 code. 240.83 is titled Marking. And we have markings requirements for durable and visible, location, interrupting ratings. And then D is used as switches, and this doesn't seem to have changed at all. Circuit breakers used as switches in 120 volt, 277 volt fluorescent lighting circuits shall be listed and shall be marked SWD or HID. So what that tells me is I can use an SWD breaker, a breaker marked SWD or HID to switch fluorescents. And then circuit breakers used as switches in high-intensity discharge lighting circuits shall be listed and shall be marked as HID. Now, if you look at the previous question, oh man, sorry about that. If you look at the previous question in my last in my last video, part 1, I would say, of the lighting, we talked about the UL requirements in 489 around HID and SWD breakers, and those requirements, from a manufacturing perspective, from a UL listing perspective, we focus more on much more durable from a switching, because in the cycles and interruption of the current based upon the phase angles and the power factor of those circuits. And we had a discussion around power factor as well. And if you recall, and I put the references out here on my LinkedIn article. I've got 3 different blogs, and there are 3 different references, just industry chatter around this topic of lighting and power factor. But we test our breakers to switch these lights out at a different power factor than we would others, and we do more cycles. So what we're saying is that a breaker that's marked HID can handle the switch, the number of switches switching, from a duration, from a durability, endurance perspective, for HID and for fluorescents, and the power factor is no worse for HID, but you can't use the SWD on an HID circuit because you need the HID breakers because of probably around the power factor that we're testing those at. So in any case, that's an important aspect of that. All right, so I'm just going to take my Menti codes off for now. All right, so that gives us that's a sort of a refresher from our discussion yesterday around HID and SWD. UL 489 for circuit breakers does not include any special testing for LED lights or LED loads. There are no circuit breakers listed differently for LEDs. Now, Having said that, if we look at, and I'm going to go down here to these references, I've got 4 references around inrush currents on LED circuits, and I'll just call each of those up, hopefully. So here is an application guide on inrush currents with LED light sources. So I guess I want to make it clear that although we don't have a specific circuit breaker that addresses, that's designed for LED type of loads, what we do know is that an LED driver will have inrush currents. That's one. There's high inrush currents with LED. I'm just going to call each of these up. And again, I'm including those in my lighting reference article that's on my LinkedIn website. So what you'll see here is that it's talking about how do I know if I'm going to have a problem, and how many LED circuits can I connect into a component on a contactor. So it's not just the circuit breakers, it's other types of devices that would be controlling LED lights that have to consider the fact that you will have inrush currents associated with the drivers of these LED circuits. And I like this reference here because it talks, it gives you a little bit more detail around, like this table here is electronic dimmer example data sheet for a product specifically designed for LEDs. So it tells us that that we may not have specific breakers designed for that, but you will have other components specifically designed for those. Let's take a look at this one. This is high inrush currents with LED lights, how to resolve any problems. And we talk about the technical background. Okay, so the inrush current is the electrical current that flows immediately after a lamp is switched on. And we think about inrush currents in what regard? We think about it with transformers, right? When we energize a transformer, we think about it with regard to motors. When we start a motor, you have inrush currents. And I would say HID and all those other types of lights, have similar inrush currents because you have a driver. And when you have a driver that either has a small transformer in it or other types of components, those will still have those inrush currents. It talks about in this article that you have inrush currents for LED lights, LED transformers, inrush current, and how to calculate that. And you'll notice here that circuit breakers or fuses may be engaged or may open the circuit if those inrush currents are too high. And that's one of the issues that I've had, and I think what raised some of this question about special breakers is that I would get a question every now and then where someone said, I have a string of LED lights, and when I turn them all on, my circuit breaker trips. And in some cases, there may be an AFCI on that or a GFCI, and they think it relates to the GFCI technology or the AFCI technology, when in fact it's really the magnetic pickup because of the inrush currents associated with that. So I put these links out here as references for you to just help you understand that inrush currents around LED lights. If you had this question in your head about special breakers, it's probably because you've had some issues with tripping a circuit breaker or opening a fuse based upon energizing those. And what you'll learn is that there are some design ideas on how many lights you should be putting on a string on individual circuits. And some of these references provide some of the math associated with helping to alleviate those problems. So in any case, let me just take a look at this last one. Inrush current protection for LED lighting circuits, branch circuits and LED lighting, LED driver current, determining the precise effect of circuit impedance and cabling impedance, calculations, steady state current, calculating total inrush current, maximum for inrush current for limiters. Now, and if you think about let me just do this. Eaton.com/TCC. That'll get you to, if you go to Eaton.com/TCC, that'll get you to the time current characteristic curves for all of our different types of overcurrent protective devices, including relays, molded case circuit breakers, and fuses. Now, if I go to, most of these are our three-phase. I'm just going to go to the EG breaker just because I just want to simply bring up a trip curve to help you understand. So this is a trip curve for our EG breaker. And the issue that you'll run into on any type of inrush current, whether it be a transformer, motor, or whatever it is going to be that you're working into this instantaneous region. And depending upon the size of the breaker, this is a molded case circuit breaker as an example, an EGB, EGE, EGS, or EGH. If I look at this, this is 16 to 160 amps. So it shows that we are in multiples of rated current. So if I am at 60 amps, then this one is, since it's multiples of rated current, that is 1 times 60. So this is 60 amps. 10 times 60 is 600 amps, 6,000 amps. You get the idea of the time current characteristic curve and how to read this. But you'll notice that that the instantaneous pickup for these devices can be either adjusted or maybe different. So the circuit breaker continuous rating, this is for 16 to 160 amps for this specific trip curve. Let me just make this a little bit larger. There we go. So I'm reading in this area right up here. So I have from 16 to 160 amps. This is the AC voltage at 60 hertz that I can apply this at. It gives me all of the information regarding that. And again, this characteristic curve, although there's one band, these are again multiples of the rating. So how I would transpose these either into SKM or some other software, or if I wanted to do this by hand, I just have to remember to do the math, because you got to look at this bottom current in multiples of rated. And then these are multiples of, that's 32 times, 40 times, actually those are the amp rating values. So these are the amps. So for different breakers, your percentages will be a little different in the instantaneous pickup. So you've got to be a little bit understanding of the type of overcurrent device that you have. If you have a tripping issue with a specific circuit breaker, then I would suggest you grab the time current characteristic curve, look at the information from the manufacturer on the drivers to see what their inrush currents are, and do the comparison. So it could be that you're tripping that circuit breaker because you're into the instantaneous region. Even if it's an AFCI or a GFCI on that circuit, I would still go back and look at the instantaneous, because just because you're tripping an electronic type of breaker like that doesn't mean you're tripping it because of the AFCI detection or the ground fault detection. It could be tripping on thermomagnetic, on the magnetic side of the business. Those inrush currents are going to be very, very fast. And some of them might come and go faster than what the breaker can respond to. But regardless of that fact, you may have a breaker that trips pretty quick. Now, it may be too that you may say, well, I turned it on this time, it didn't trip, and I've turned it on 4 or 5 times, and it didn't trip, but this one time it did. And that could simply be because of where you're closing in on the closing angle on the sine wave. So that makes a difference. All right, so hopefully you got a little bit out of that one. And make sure that I don't have any questions on that yet. So are my AFCI, GFCIs, or breakers ALSO rated or as SWD or HID? Switch rated breakers, most of these breakers are all SWD for switching duty. I think it would be hard. I don't know if I have. Let's take a look at some pictures. So Brian Rock had a question. I'm going to go back one here. on questions. I'm going to open up some pictures, and I believe, let's go to products, LMNOP products. The other thing, as I'm looking for this, the other thing to remember too, we do sell high magnetic breakers. Remember, I could have a breaker that has a higher magnetic, that as long as it's say SWD rated, or it doesn't even have to be SWD rated in the case of LED lighting, but a high magnetic pickup could help you live through that as well. And my suggestion would be to call the manufacturer and say, hey, I am having some tripping issues. And if you're looking at the trip curve, you can call the manufacturer and ask them if they have a high mag. We call them high magnetic, where we bump that instantaneous pickup way up. And that may help you live through the tripping issues. So I'm just going to open. Photos are already enhanced. I'm going to open in, let's see, I've got some AFCIs here. Let's take a look at this. So I have, here is our AFCI, combination type AFCI, single pole, copper, aluminum. This is listed. I don't see anything on there that says SWD or HID. This is listed as a combination type. And I should have a picture of the side as well. Let's take a look at this one. So use only on listed enclosures, see safety, max RMS, CTL, maximum RMS. So no, I don't have any HID rating on this, and I don't have a SWD on that one. That's an older breaker. This is actually an older breaker. Let's see how we used to do it in the past. I can't read that one close enough. Well, I think that was a better quality. No, it wasn't. Let's take a look. Let's take a look at this one. Single pole issue, also listed as combination type AFCI, class CTL. So I don't have HID or SWD on the AFCI breakers. And again, remember what the SWD HID gets you. We assume that you're going to be using the breaker to turn things on and off. That's just how it's packaged. All right, so I don't have SWD to answer your question, Brian. No SWD, doesn't look like SWD nor HID. Not rated separate. Okay, we got our AFCIs, GFCIs also rated as SWD, HID. So I would have to answer that as, based on the images that I have, I would have to say no, that would not be the case. I don't know. I might have an AFCI over here as well. It's better now. Okay. Let me just go out to Facebook and see if I have any questions out there in Facebook land. I hope I didn't close my Facebook. All right, so we got Mark. Oh, Mark Yerse is out there. Bill Neitzel. Okay, Jason Moore. All right. So okay, so that seems to be good there. So we are going to move on to question 10. All right, question number 10. I believe we're on question number 10. Are specific types of dimmers required? Minimize that. I need to see what I'm seeing when I saw it. Bear with me. There we go. Are specific types of dimmers required for various types of lighting? Incandescent, fluorescent, HID, and or LED. We saw a little bit of this already. We had a little bit around this discussion. I would say each type of those lighting sources, they have, and we talked a little bit about from a inrush current. We talked about it from a power factor perspective. We know that each types of these each of these types of lighting will have different characteristics from a load profile perspective. So it's important that we use the right technologies to turn them on and off when those technologies are, especially if there's specific listing requirements or specific labeling around the product themselves. So incandescent and halogen, line voltage tungsten filament amps, again, they're a resistive load and rated for cold filament inrush. Don't use magnetic low voltage or electronic low voltage. Do not use on magnetic low voltage, MLV or ELV. The magnetic MLV, magnetic core transformer supplied low voltage lighting, that's an inductive type of load, symmetrical cycle, smooth turn off, includes a transformer losses when calculating the load. And electronic ELV, electronic solid state transformer supplied low voltage lighting. These are capacitive types of loads, but you can get a very smooth turn on with neutral wire connection. Neon cold cathode, magnetic ballast. These are very inductive type of loads. There are special requirements, symmetric cycles for smooth turn on and off. They included transformer issues when calculating the load, low end capabilities and whatnot. And then you have your fluorescents. They're special dimmers and designed from a UL perspective for those applications. And there's another one here too. So these are your light emitting diodes, LED drivers. Special dimmers are designed to send power and control signals. I don't know if you've ever had this before. I know when I installed some of my lighting controllers, I think I had a dimmer switch. I had some LED lights and some fluorescent lights on the same circuit, and I started to get a pulse between them all. I ended up having to change my lights out all to one, and I think it was the compact fluorescents that were giving me the issue. And I didn't change my my dimmer switch, but I could have changed the dimmer switch to handle the loads as well. So you can end up running into some of those issues. So I took a snapshot out of one of our catalogs from a wiring device perspective. You have you're seeing here, you have your common lighting loads. So these types of switches that you have can be used on dimmable, compact fluorescents, electronic magnetic ELV and MLV, incandescent halogens, fluorescents. So you'll see that the solution, the wiring device, the lighting control device that you would, whether it be a dimmer, an on and off, or a motion sensor with dimmer, they'll tell you the compatible lamp loads associated with them. For example, on this one here, you have a column that says compatible lamp loads specifically, and it tells you which lamps you can use in that application. So I'll just do this real quick. This is probably a better way to talk about it rather than cut it out of a sheet. But in any case, so this is our catalog that we have for universal dimmers and dimming done right. I like that. Eaton's universal dimmers. So you have to be aware of what dimmer that you're using for what, and the loads, and the manufacturer's information and literature will give you that information. So as I pointed out earlier, this shows you what rated for common lighting loads. What are those common lighting loads that you can use this on? But not all of your dimming switches are able to handle all the types of loads. So you really have to go back to the manufacturer and understand what you're buying and what the lighting load that you are installing. And obviously, the more versatile the controller is, the better off you are. All right, since AFCIs are only required in dwelling units, and since it is uncommon for breakers to be used as switching devices in dwelling units, there's no real need for an SWD. Okay, typically dormitories use 277 volt lightings. I do not think 277 was allowed in dwellings. Yep, that's true. Perhaps, but I've seen in dormitories and colleges. Yep. All right. So there's just a discussion going on YouTube. So I'm referencing this so that you understand that you will have to marry your controlling device, the light switch, the occupancy sensor, whatever it is, with the type of load that you are dealing with. All right. So I don't have anything else on that. I see on YouTube land, and I'm going to take. Okay. So question number 11. Does the NEC include special requirements for luminaires used in indoor sports, mixed use, and all-purpose facilities? If so, are the requirements the same for all types of lighting? If not, why? Good question. Let's take a look. So if I look at part 2 in Article 410, so we're going to move up to Article 410. Boom, 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 boom. And remember, 410 is luminaires, lamp holders, and lamps. And I'm going to 410.10 luminaires. So part 2 is titled luminaire locations. So that and again, you know, it's part 1 was probably general. Yep, part 1 is general. Part 2 is luminaire locations. So you would think that that's exactly where you need to go. 410.10 is titled luminaires in specific locations. We've got A is wet and damp locations, B is corrosive in locations, C is in ducts or hoods, D is bathtub or shower areas, E is luminaires in indoor sports, mixed use, and all-purpose facilities. It says luminaires subject to physical damage using a mercury vapor or metal halide lamp installed in playing and spectator seating areas of indoor sports, mixed use, or all-purpose facilities shall be of the type that protects the lamp with a glass or plastic lens. Such luminaires shall be permitted to have an additional guard. So, I think you can get the gist of what's going on here. You have a technology that has some components that you would not want to just spray over everybody if it becomes jeopardized. So in these arenas, you might have some sports things going on. You have balls in the air. You've got javelins in the air. You've got your shot put. I don't know. I've never thrown a shot put, but I'm sure that those are people that can really lob that puppy pretty good. So the desire is to protect that technology and pretty much provide protection so that you don't break that lamp and it doesn't shower down on people. That would be my guess in that regard. It doesn't specifically say that in the NEC, but it does provide protection, and that would be probably the reason why. Sports. I know that we have special lighting for the sports arena events, not just from a protection perspective, but for other reasons as well. And now this specifically talks to metal halide and mercury vapor. Now, if I'm using LED lighting, I wouldn't have that same requirement because you just don't have you don't have that same vulnerable. You don't have the gas discharge lamps and electric lamps and things of that nature. So the answer to this one, I would say for the first one, does the NEC include special requirements? I would say yes, and we just highlighted that in 410. If so, are the requirements the same for all types of lighting? And I would say no. They specifically called out a specific type of lighting. And then if not, why? It's because. I mean, the only thing I could tell you is those types of lights, you want to make sure that you protect that. They have components inside that could probably, you don't want to release out into the environment and the atmosphere should it get hit. You don't have that same issue on LED lighting. This is like the sports lighting for that Cooper Lighting Solutions offers. These LED lights are very bright. You don't have the same concerns that you would have on our metal halide or mercury vapor lamps, right? And again, the other benefit that you have from an LED type of light is its service life. You don't have to replace those as often, which means you're getting people out of harm's way and focused more into other areas of the facility, as opposed to getting on ladders and scaffolding to change out lighting. So the longer that we can prolong the replacement of lighting, the better off I believe we are. So let's take another quick look. I'm going to move that keyboard out of here. I keep flipping that one. So let's take a look at, I'm going to be getting on to question 12, but let's take a look at our chat. Dormitory units not included. Okay, occupancy limitation in dwelling units and guest rooms. So there's a discussion going on out there with regard to dormitory units, 210.6A for 2023. No requirements for AFCIs and 277 volt circuits. That's right. So we're only on 120 volts and 240 volts if you're doing shared neutrals. David Engelhart, so it looks like Brian Rock and David Engelhart are going back and forth. Unit not included, Tom. Should we include dormitory units in 210.6A for 2023? So let's take a look at 210.6A. I don't know if you can hear my doggies barking up there. 210.6. 210.6A. 210.6 is branch circuit voltage limitations. And occupancy in dwelling units and guest rooms or guest suites of hotels, the voltage shall not exceed 120 volts nominal between conductors to supply terminals of the following: luminaires, cord and plug connected loads. So what Brian is saying that should we include dormitory units in 210.6A? I'm not sure. I mean, that might be a decent. I'm not sure about that one, Dave, Brian. I don't know yet. I'd have to take a look at dormitories to see what they're doing. My gut tells me I would agree with you, but then we probably could throw some other occupancies in there as well. We should do a review of that, just to be sure we're not hurting somebody. In dwelling units and guest rooms or guest suites, hotels, motels. Okay, we saw that. Don Gannier is talking about also requires special construction for fixtures that use in metal halide lamps. That's right, yeah, 410.130F5. 410.130F5. That's a good point. 410. Let's take a look at that. 410.130F5. Oh, you know what? I'm opening my book. I do believe that I have the code book open here somewhere. There we go. So 410.130F5. 410.130F5. So let's take a look down here at 410.130F5. I'm going to zoom in so that we all can see that, and hopefully everybody is connected. 410.130. 130F. F is high intensity discharge luminaires, so that would be very pertinent to the discussion of question number 11. Talks about recessed high-intensity luminaires designed to be installed in wall or ceiling cavities shall have thermal protection and be identified as thermally protected. There should be inherently protected. F2 is thermal protection shall not be required. Shall not be required in a recessed high-intensity luminaire whose design, construction, and thermal performance characteristics are equivalent. Installed in pour concrete shall not be required in recessed. And F4 is recessed remote ballast. A recessed remote ballast for a high-intensity discharge luminaire shall have thermal protection that is integral with the ballast and shall be identified as thermally protected. And then you get F5, which is what Don Grenier was pointing out. Metal halide lamp containment luminaires that use a metal halide lamp other than a thick glass parabolic reflector lamp shall be provided with a containment barrier that encloses the lamp, or shall be provided with a physical means that only allows the use of a lamp that is type O. Now, here's where my thoughts are. This is that when you get into these types of requirements, or from a National Electrical Code perspective, I'm sure if I went to the listing requirements for these types of devices, a manufacturer could not make a metal halide lamp containment that did not meet this requirement because it's in the standard. Now, who drove who? It could have been in the standard and they decided to make sure that they put it in the code. Some of the reasons why they would want to put that into the National Electrical Code would be in case you're buying something that's maybe not listed, if it's not required to be listed. This gives the electrical inspector something to look at to say, to qualify that product. Like I say, especially if it's not a listed product. And if it's not required to be listed. If it's required to be listed, then, and that should be a part of the listing from a UL standard perspective. So every one of these lights, anything that has a metal halide lamp and the containment should be meeting this, this requirement. So in any case, that was a good, healthy discussion, and hopefully we got something out of that one. So I don't see anything else coming in on that. I'm going to double check Facebook. Let me just break this out separate. Double check Facebook as well. All right, so nothing there and nothing on YouTube land. And I'm just going to I'm going to close that. I'm going to close some of these things that I have up here, some of my notes from earlier discussion. All right, close my LinkedIn. Okay, so let's get back to our discussion at hand, and we are on question number 12. Does the NEC include special requirements for luminaires installed in closed closets? If so, are the requirements the same for all types of lighting? If not, why? All right, so I would reference sections, and I'm going to bring up the code book again. I'm looking at sections 410.16, 410.11, and figure 410.12. So 410.16, let's take a look at this one. 410.16 and 410.11. 410.11 does come before 16, so I would say we go there first. So 410.11 says luminaires near combustible material. Luminaires shall be constructed, installed, or equipped with shades or guards so that combustible material is not subject to temperatures in excess of 90 degrees Fahrenheit. So you don't want that touching, right? So that's 410.11. We did mention 410.2 as well. So there's our image for in 410. Whoops, 410.2. There we go. Hopefully that's all on the screen. So we have some good closed closet storage space. Now, we did make a change in the 2020 code cycle that 410.2 went to say closed closet storage space. Now that would seem to indicate, and I'd have to look at the substantiation on this one, that if I have a closet that stores towels, I don't have to follow this guide. Or if I have a closet like a pantry closet that has canned foods and things like that, I wouldn't have to worry about this anymore. Where before I may have had to have worried about this because it just said closet storage space. So now it says closed closet storage space. So that's an important NEC change. So that's 410.2. So that gives us the dimensions. And if we go to 410.11 again, that talks about luminaires constructed. So I want to have some protection. And then there's a specific section on luminaires in closed closets, and it tells you the types that are permitted. Only luminaires of the following types shall be permitted in a closed closet. You know what? Let's take a look at the 17 version in 410. because it could be they just aligned the title. So 410.16 in the 2017 version of the NEC did say luminaires in clothes closets. And then the diagram said closet storage space. So it looks like what they did in the 2020 code cycle was they changed the title of this image from closet storage space to clothes closet storage space, because it's probably the only reference to that image is actually in 410.16, which talks about luminaires in clothes closets. So now, if that's the case, what I would have suggested is that should be a figure 410.16. And 410.2 is always, well, no, there's a definition. So clothes closet. So they changed the definition of closet storage space to clothes closet storage space, because apparently closet storage space isn't used anywhere. And that's interesting. So it looks like they did an alignment with where the terminology is being used. So closed closet storage space is defined as the volume bounded by the sides, back, closet walls, and planes, extending from the closet floor vertically to a height of 6 foot, or to the highest closet hanging rod and parallel to the wall. So hanging rod sort of gives it away that it's got to be a clothes rod, because if it was a pantry, or if it was a closet that was for towels, you wouldn't have a hanging rod. Or to the highest close hanging rod and parallel to the walls at a horizontal distance from the sides and back of the closet walls, respectively, and continuing vertically to the closet ceiling, parallel to the walls at the horizontal distance of 12 inches or the width of the shelf, whichever is greater. For a closet that permits access to both sides of a hanging rod, this space includes the volume below the highest rod extending 12 inches on either side of the rod on a plane horizontal to the floor, extending the entire length of the rod. All right, well, I hope that helps you understand that one. And if we go back down to 410.16, luminaires and closed closets, it tells you where to place these. Types not permitted: incandescent luminaires with open or partially enclosed lamps and pendant luminaires or lamp holders shall not be permitted. And it talks about the location, the minimum clearance between luminaires installed in closed closets and the nearest point of a closed closet storage space shall be as follows. So they were really, they crossed their T's and dotted their I's with using the word clothes, cloths or clothes throughout 410, it looks like. So space for cove lighting is next. So in any case, let's get back to the question. And what was the question? Does the NEC include special requirements for luminaires installed in closed closets? I think the clear answer to that is yes. We reviewed 410.11, 410.16, and figure 410.2, plus the definition found in 410.2. Are the requirements the same for all types of lighting? We saw that, and we saw that it is not the same. And I would say, I would go back, there's a couple factors here. One is around the heat. I think it's all primarily around the heat of those lamps, because you don't want to ignite anything that is flammable if you come in contact to them. And if you think about a closet, you've got a closed-in space. If you're touching the fabric, you could melt that fabric, you could ignite that fabric, because it's probably not going to be moving around. There's definitely no wind moving anything around and whatnot. Looks like the main 410.16 content and 410.2 definition correlates to the title. Yes, that's exactly right what they did, Brian, as they correlated that. So Don Gannier pointed out a closet for towels would present the same hazard if there are storage shelves close to the location of the luminaire. And Don, I agree with you 100% that you are presented with the same hazard, but I would say that if you look at, even what they changed didn't change our requirements, because we have specific requirements for closed closets in 410.16. So let's do this. I'm going to open up the 17 book real quick. I'm not sure if I can do anything quick on this computer, but I am going to open up the 17 code book, and we're going to do a quick search for... I'm going to do a quick search. I got to put my code books down. Actually, it just opened up over there. So we're going to do a search for what was the terminology that we saw in the book? We saw closed closets. We're just going to do a search for closets. Oh, wait, what was the definition? The definition change was closed closet storage space, closet storage space. So let's search the NEC, Control F, closet storage space. So we're going to check the 2017 version of the NEC for the term closet storage space. We should find the 410.2. We should find 410.16. Closet storage space. I got classified. I don't know how I get classified out of closet storage space. Let me put this in quotes. I love Adobe, but closet storage space. Closet storage space. Closet storage space. Let's just search for closet. Here's the definition. Closets in 410.2, just like we said. Location for closets, enclosed closets, nearest point of a closet storage space. All right, so the minimum clearance between luminaires installed in closed closets and the nearest point of a closet storage space. Well, we don't have the definition of a closet storage space anymore. Let's check the 17. This is 410.16c. 410.16c. 410.16c, yeah, closed closets and the nearest point of a closed closet storage space. So they did make a significant change here to remove the requirements from those other types of closet storage spaces. So Dawn, you have a point, in my opinion, that they did remove that from any type of closet space. I was going to make the argument that all of these, well, I could still make that argument because 410.16 talks only about closed closets, yet down in this area we had closet storage space. So let's just continue our journey here through the code for closet. So let's get out of 410.16 to see, are there any other areas where we use that term? 410.16 luminaire. Okay, we already went over that. In closets, other than those as 424. So now we're into fixed electrical space heating. So no, there's nothing in 410 outside of a closed closet. Even in the title of 410.16, it says luminaires in closed closets. Now, I don't disagree with you, Dawn, but I would argue that even in the 17 and earlier versions, we still didn't have that requirement that we see here. So I would argue that that we've never had a requirement for those types of applications, and this really solidified. If there was ever any debate, if you had a closet that was for linen, sheets, and towels, you could probably make an argument that per 410.16c, because it's said in the past the minimum clearance between luminaires installed in closed closets and nearest point of a closet storage space. You could try to make that argument to say, look, closet storage spaces, regardless of whether or not it's a closed closet, does apply because of that language. But if I was the inspector, I'd point up, or if I was the contractor, I'd say, look, this is in 41016, which is closed closets only. There is not a requirement in 410 around anything other than a closed closet. So that's an interesting point. All right. Well, that was a fun little journey, wasn't it? At least I think it was. All right, so I think that is, I'm going to continue question 12. Luminaire types permitted, and we already talked about this. Only luminaires of the following type shall be permitted in a closet, and they talk about the recessed incandescent, and they talk about the LEDs. Surface-mounted or recessed incandescent LED luminaires, surface-mounted or recessed fluorescent luminaires, and then fluorescent or LED luminaires. So they pulled out that incandescent bulb out of there. Not permitted incandescent luminaires with open or partially enclosed lamps, and pendant luminaires or lamp holders shall not be permitted. All right, and then they have the location, and we just looked at this and some of this has changed, right? So I would the language that I was showing previously was based on the 17. You'll notice what they said here in the 20 code. Again, closed closets, surface mounted LED. This is with regard to location, and all the different distances, and then space for, and then that space for code language. So you have A, B, and C to think about with regard to a closed closet. If it's a linen closet, if it's a pantry closet, if it's any type of storage closet that doesn't have a place for you to hang clothes, that brings up another question. Okay, does a closed closet? Well, let's take a look at the definition, because I was just sitting there thinking I could have a closed closet. It could be nothing but T-shirts that I fold and put on shelves. So let's take a look at that. The volume bounded by the sides and back closet walls and planes extending from the closet floor vertically to a height of 6 foot, or to the highest closed hanging rod and parallel to the walls at a horizontal distance from the sides and back. So my question would be, if I don't have a rack, if I don't have a post, if I don't have a post, does that mean it's not, that it could still be a closed closet? Because a close, let's do this. Merriam-Webster, Webster Dictionary, DICT Dictionary, close. Right? So if I look at the definition of clothes, clothes is not just something that you would, it's, clothing. So it's basically clothing. And clothing could be T-shirts. It could be dress shirts. It could be pretty much any of those things. And it doesn't necessarily have to hang off of a hanger. So it says closed walls and planes, okay, or to the highest closed hanging rod and parallel to the walls. So if I could make the statement that a closed closet storage space, even if it is nothing but shelves. Now, if it's in a kitchen, I'd have a hard time arguing that's a closed closet. If I have something inside of a bathroom or in a bedroom that would have nothing but shelves and a door, I could make an argument that that could be a closed closet based upon the area. But it doesn't seem to be that I have to have a rod for hanging clothes for it to be a closed closet. But I think after all of that discussion, in my opinion, we need a better attention in 410.16 and 410.2 and 410.11. A good public input's probably worthwhile there. All right, so I'm going to take a look at some questions. Okay, so we got Gary Beckstrand, other combustible materials covered in 410.11. Yes, linens are covered. 410.11. So Gary Beckstrand saying we've got other closets in 410.11. Ah, very good point, Mr. Beckstrand. In 410.11, it says luminaires shall be constructed, installed, or equipped with shades or guards so that combustible material is not subjected to temperatures in excess of 90 degrees C. And then there's luminaires over combustible material. Lamp holders installed over highly combustible material shall be of the unswitched type. Unless an individual switch is provided for each luminaire, lamp holders shall be located at least 8 foot above the floor or should be located or guarded so that the lamps cannot be readily removed or damaged. So to Gary Beckstrand's point, you have the luminaires near combustible material in 410.11 and 410.12 luminaires over combustible material. But there are special requirements. 410.16 tells us what types are permitted in closed closets, and a lot of those details are not included in 410.11 and 410.12. Like, for example, 410.11 and 410.12 does not tell us that we can't use incandescent luminaires with open or partially enclosed lamps, and pendant luminaires for lamp holders are not being permitted. I could use those if it's not a closed closet. And the question would be, should we have those restrictions? Should we be opening 410.16 to other types of closets? That's, I guess, the $1 million question. Okay, how about LED tape for lighting the closet? Yeah, I mean, LEDs, there's, again, surface-mounted recessed incandescent LED luminaires with completely enclosed light sources. So I would say tape, that type of strip, LED strips are very much permitted. All right. Other combustible materials, 410.11, 410.12. Veneer is not specific enough. 410.11 is not specific enough, and 410.12 goes away if I provide a separate switch for each luminaire. That's exactly right, Dawn. And that's why I'm sitting there saying I believe, in my opinion, we should be looking at 410.16 and expanding to a point where 410.11 and 410.12 could even possibly go away. Or maybe not. I'm not, the 410.11 and 410.12 would apply even if it wasn't a closet, right? But I would just remove the word close from 410.16. Get rid of the closed closet. Just say if it's a closet, these are the things you can put in a closet, because these still have the same hazards. Okay. And the reason I would say from a shelving perspective is, the distance between the end of the shelf and the door is really what you're thinking about. And can I put my towels or anything, or not necessarily the door, but from where my lamp is, if I have a very shallow closet and my lamp is on the inside upper portion of the above the door, I've seen them put there. I've seen them put on the top, but on the shallow ones, I've seen the lamp basically right above the door on the inside of the closet. So that's a good discussion. Very good discussion. All right, moving on. We're going to 13. The NEC indicates in 410.18 coves shall have, I got to get my PowerPoint so I can read. Coves shall have adequate space and shall be located so that lamps and equipment can be properly installed and maintained. What does that requirement mean to designers, installers, and authority-having jurisdictions? Provide examples of permitted and non-permitted applications. Would the requirement be the same for all types of luminaires? So 410.18, if I look at the code book on 410.18, it says, it's one sentence: coves shall have adequate space and shall be located so that lamps and equipment can be properly installed and maintained. That seems to be very generic. What is adequate space? That is a good question. Now, I grabbed a couple images. Here's an example, 410.18. So this is there's the language, which is a simple one sentence. There's an example of cove lighting. Here's another example of cove lighting. If I can get my computer to change. There's another example. I think I took that picture at one of the NFPA technical committee meetings in the restaurant area. So the question is, what is adequate space, and what is, for working space? And I think that in some of these, it could be pretty vague. That's pretty vague language that I could make arguments on whether or not I have enough space to work on those. And some of those LED lightings are you just push them down and you can basically pull them out. So let's go back to the question. The question was, what does that requirement mean to designers, installers, and AHJs? Obvious that what it means is you're going to have to design it so that lighting like this is accessible. It can be maintained, meaning if I have to change a bulb, I have to change a light strip or whatnot, I'm going to have access to that. There's various ways to get that done. Permitted and non-permitted applications. I couldn't find too many good images. I don't know if anybody else has images. These are a couple of the images that I saw. And, I don't know the intricate details around these designs because I didn't get on a ladder and climb up in there and take a look at it. But, I know that some inspectors I've been with have pointed these types of images out, this one and this one in particular, and said they either would or wouldn't have permitted that because you don't have access to those without either removing the molding or some other method to get access to those components. But we're going to have to be able to provide that access that is required based on 410.18. And it says, would the requirements be the same for all types of luminaires? And yes, if I look at the language. If I look at this language here, it says coves shall have adequate space and shall be located so that lamps and equipment can be properly installed and maintained. There's nothing in there that says anything about whether or not it's an incandescent, an LED, or whatnot. You just need to have that space to be able to work on it. So I don't have any better response other than that. And I don't know if anybody out there in tube land would have good notes on how you make that accessible. And Brian, you noted, Brian Rock notes that cove lighting access the LED drivers equipment. Yes, you do have to access the LED drivers, but the lamps themselves, the LED lights, you'd have to access those as well. Now, if in some of those applications, I may have just an area where I'm popping in the lights. I could reach in and pull it out and then replace the whole strip because some of that's like a string light and you just plug them in. I don't need much access. As long as I can reach my hand in there and pull it out, I'm good. But I do have to be able to replace any of the LED drivers, and I have to have clear access to all of that. All right. And I'm going to take a quick look out on Facebook land, see if there's anybody out there who has any questions. Please put in any questions that you might have or clarifications. Share some of your knowledge in regard to the topics that we're discussing. All right. So we are going to get back to IM3 with me. Okay, so luminaires Are all luminaires suitable for installation in dry, damp, and or wet locations? I think we all know the answer to that one. Where is the dry, damp, and wet location markings located on the luminaires? So that's something that we can explore. So with regard to are all luminaires suitable for installation in dry or damp and wet locations, we're referencing 410.10 in the code book, and I would look at part. And again, we're in part 2, luminaire locations, which makes sense. 410.10a talks about wet and damp locations. Luminaires installed in wet or damp locations shall be installed in such that water cannot enter or accumulate in wiring compartments, lamp holders, or other electrical parts. Let's make this a little bit bigger. I wish I could get rid of some things here, but I can't. 410.10. So luminaires installed in wet and damp locations shall be, okay, so all luminaires installed in a wet location shall be marked suitable for wet locations. So we know that there's a marking requirement. Luminaires installed in damp locations shall be marked suitable for wet locations or suitable for damp locations. So it says all luminaires installed in damp locations. Okay, so what that's telling us is if I have a luminaire that's marked for a wet location, I can use it in a damp location. Duh. Right, so that's pretty straightforward. If I look at here's an image of a light that says suitable for damp locations, and for electrical ratings, refer to ballast. Fixture must be installed in accordance with all national electrical codes, and fixture must be grounded for safety and proper operation. So this one shows us very clearly that. Right in here, again, that it has to be suitable for damp. That's suitable for damp locations. And here is one here. This is a Cooper Cross Hines, and it says right up in here, suitable for wet locations. Okay, marine outside type enclosure 4X IP66. Disconnect power for usage. Use lamp as specified. Use base up only. So you've got to follow all of the instructions because all of the whole concept of damp and wet locations are applicable as long as you're installing it per the manufacturer's instructions. And you take a look at this fixture here; it really shows you how it's supposed to be installed on the unit itself. That's purely, that is a wet location. It's obviously a wet location. The configuration of this unit, in how it's facing, it's probably not being listed to point in the up direction, but it may or may not, as long as the information on that product doesn't specify. This is, I would call this more so a damp location than a wet location. I don't know about what you guys are thinking, but I would call that a damp location and not necessarily a wet location. And all of these lighting fixtures have to be listed for that application, and they will be marked. The electrical inspector will obviously check that out and make sure that that you're meeting those requirements. So with regard to 14, are all luminaires suitable for installation in dry and damp and wet locations? I would say no. You have to have it listed for that application, and it says where is dry, damp, and wet location markings located. We saw that as part of the instructions, as part of right on the units themselves. All right, so before we go to the next question, I'm just going to take a quick look at any questions that we have out here. All right. Anything out in tube land? Bottom line, no carbon arc lighting in coves. That's true. Very true, Brian. Okay, let's look at the shelves above the hanger rods. All right, I like it. Stream health. I'm looking at my stream health. Analytics, 46 concurrent viewers, 97 playback, so we're looking pretty good. All right, so let's take a look at the next question. We're going to question 15. How do designers, installers, and AHJs know when special installation requirements exist for orientation, connection spacing from combustible materials and air movement is needed for various luminaire types. Should we assume the needs and requirements vary from one luminaire to another? That's a good question. You have to rely on the reference, NEC, and manufacturer instructions, obviously. So you're always going to be looking at the manufacturer's instructions. And if you recall, this in the previous question, we saw this marking. It says luminaire for hazardous locations when completely assembled with UL listed fixture fittings, where marked, blah, 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 suitable for wet locations, marine outside type. And it says disconnect power, use lamp as specified. So there's detailed information on some of these luminaires when it is applicable. Any combustible wall, so in 410.23, I'm just going to go over here to the code because I like using the latest version of the National Electrical Code. Covering of combustible material at outlet boxes, any combustible wall or ceiling finished exposed between the edge of a luminaire, canopy, or pan and an outlet box having a surface area of 180 square inches or more shall be covered in with non-combustible material. So that's in 410.23. We also have in 410.70, let's take a look at 410.70 is another area that speaks to this discussion point. Combustible shades and enclosures. Now this is new. In the 2020 code, airspace shall be provided between lamps and shades or other enclosures of combustible materials. So that's a generic requirement. This is in part 6. So let's take a look at what part 6 says. Part 6 says wiring of luminaires. So it doesn't say any specific type of luminaires. It's just wiring of luminaires. And if we look at .70, it tells us airspace shall be provided between lamps and shades or other enclosures of combustible material. So that's another example point. And let's take a look now. This is part 7, construction of luminaires. Part 8, installation of lamp holders. So let's take a look at it. That installation of lamp holders in 410.97 tells us near combustible material, lamp holders shall be constructed, installed, or equipped with shades or guards so that combustible material is not subjected to temperature in excess of 90 degrees C. 194 degrees Fahrenheit. So in addition to the 410.11 discussion, etc., we do have these other areas, other requirements that would bring us back into that linen closet or any of those other areas. These would be your references around the proper application, because let's just remind ourselves of the question again. How do designers, installers, and AHJs know when specific installation requirements exist for orientation, connection, spacing from combustible materials, and air movement that's needed? So we're going through the different parts in 410 that cover those areas. In 410.97, 410.70, 410.23 are all areas, and 410.1 or 104. Electric discharge lamp, auxiliary equipment. Auxiliary equipment for electric discharge lamps shall be enclosed for non-combustible cases and treated as sources of heat. So I think what you're seeing is the bottom line is on a lot of this, you're going to be bouncing around the National Electrical Code to pick up all of those areas that you're going to have a requirement. 410.115 temperature is, luminaires shall be installed so that adjacent combustible materials will not be subject to temperature. So 194 degrees seems to be the number that we're looking for. So that's combustible material. Recessed incandescent luminaires have thermal protection and shall be identified as thermally protected. So there are requirements throughout the NEC that are basically peppered to help us understand the proper application. We have to understand the type of luminaire that we're installing, what type of lamp that's in that luminaire, and then go to the appropriate sections. 410.115, all of these other different areas of the NEC. And I believe 410.16 talks about clearances and installation. So you got Recessed luminaires that is not identified for contact with insulation shall have a recessed part spaced 1/2 inch from combustible materials. And I would say this gets into your can lights as well. Can I put an insulation around the can light body? If it's not rated for that, then you can't, because insulation of the fabrics and whatnot those can be combustible materials. Recessed luminaire that is identified for contact with insulation type IC shall be permitted to be in contact with combustible materials at recessed parts, points of support. So you got to think about that from not just what's on this side, but what's on the other side of that ceiling as well. All right. And then we are in 410. Let's just continue our journey down. In 410.118, we have access to other boxes. Luminaires recessed in ceilings, floors, or walls shall not be used to access outlet, pull, or junction boxes or conduit boxes, unless the box or conduit body is an integral part of the listed luminaire. So that's another important part of that. And in 410.119, luminaires shall be constructed such that spacing, adjustable computers are not subject to material. So again, 194 degrees seems to be a common number in regard to combustibles. And then if we continue our journey down through this Article 410, we should come into, we already talked about 130. We should come into 136, I believe, luminaire mounting, exposed components, combustible low-density cellulose fiberboards. So we're addressing different types of fiberboards that may come into contact. So this one here talks about surface-mounted luminaires containing ballast, transformer, LED drivers, or power supplies to be installed in combustible low-density cellulose fiberboard. You may think of an LED light as being very low temperature, but that's not true. Those drivers and whatnot, they can put off a lot of heat, and our goal in an LED light is to get the heat off. So you'll see those LED luminaires have heat shields and whatnot to draw the heat off. And then the combustible low-density cellulose fiberboard includes sheets, panels, and towels that have a density of 20 pounds per cubic foot. So there are there's a lot of locations in the NEC to help us understand the proper application of lighting in general, various types, and the concern there is about the heat that they put off and the proximity of that heat to combustible materials. And as you can tell, there are various areas in the NEC that address either what can and cannot be installed in certain locations, and then how far away from combustible materials those fixtures need to be placed. All right, so before we get on to the next one, I'm going to take a look at some of my YouTube and Facebook comments if we have anything in there. Cove lighting, okay, we talked about that. Bottom line note, we talked about that. Lamp holders versus luminaires. Yeah, we talked about the difference between lamp holders and luminaires in our session, in our first session. 410.118 is a huge change for hard ceiling type applications where in the past we have removed light fixtures for access to the junctions box. Yes, 410.118 is what Don Guinier is referencing, and let's take a look at 410.118, access to other boxes. Luminaires recessed in ceilings, floors, or walls shall not be used to access outlet, pull, junction boxes, or conduit bodies. Now, that is a big change, and that was your ceiling tile, your ceiling lights that would typically go in those, maybe 2 by 4? I think it would be about 2 foot by 4 foot areas where you would have a lighting fixture, and then they would just basically pop that up, move it over to get access. You can't do that anymore. So you have to have complete access to all of those boxes. You can't put them behind the lighting fixture. Lay-in type fixtures were installed in plaster rings in those hard ceilings and junction boxes above the fixture and fixture whips to supply the power to the fixture. That is true, yes. So 410.118 is a big change and something that we have to think about from a design perspective. All right, let's how we say, let's take a look at our Facebook. Any comments on Facebook? We got Bob Baird, Mike Warwick, Richie Pasquale, excellent. And Susan, thanks for joining us. I don't know if you guys are still on out there, but thank you for joining us. Brian Myers, and we got one comment. That was me. That was, I had said we were going live. I'll just say, please add any comments or questions. Thanks for joining on Facebook. Alrighty then, your number still 911. Let's move on. Okay, question number 16. Are all luminaires suitable for cord connection? If not, how will designers, installers, and AHJs know the limitations of the specific luminaire? Right off the bat, go to the manufacturer's instruction sheets and information. That's how you know what a luminaire is capable of. You just can't rely on that it's a listed product, because I could have a luminaire that's listed, but there are those subcategories of what you can and cannot do that'll be either marked on the product and be associated with the catalog number. So always reference the manufacturer's information. So section 41062 is the code reference. Hopefully, I don't know if I'm not showing it. So let's do this. 3 with me. This is the question. Are all luminaires suitable for cord connection? If not, how will designers, installers, and AHJs know the limitations of the specific luminaire? So that's the question. Unfortunately, I wasn't showing it there for the last one. So I would say we're going to be going to 410.62 is the code reference, and you're going to be following the instructions. 410.62. So are all luminaires suitable for cord connection? 410.62 is covering cord-connected lamp holders and luminaires. And 410.62a talks about lamp holders, where metal lamp holders attached to a flexible cord. The inlet shall be equipped with an insulating bushing that, if threaded, is not smaller than a 12 trade size pipe size, 3/8 pipe size. So there are requirements in 410.62 that deal with adjustable luminaires, and then LED luminaires. For electric discharge, LEDs shall comply with C1, C2, C3, cord connected, listed assembly in compliance with the sections in 410C1 through A through C. Luminaires shall be permitted to be connected with a cord terminating in a ground type attachment plug. They added this in the 2020 cycle. If grounding is not required in accordance with 41042, a polarized type plug shall be permitted. So here, these are basically your requirements for around what you can do with a lamp holder. Okay, 410.62 is your reference, and that has all the details. Now, I will say that if we look at the UL standard for lamp holders, it tells us that lamp holder pendant type is a lamp holder intended to be supported and suspended by a flexible cord. So you will have a listing, and it will be tested as a pendant type lamp holder. And 496 talks and it has requirements around how we test and how we're supposed to, the performance requirements around the listing of these types of solutions. Threaded insulating bush shall not be, and you'll see how some of these requirements from a UL perspective align with what we see in the National Electrical Code. So this is 442, talks about cord pendants, and then there's the cap and shell, talks about the metal pendant cap shall be provided with a bushing of porcelain, phenolic or cold molded composition or other insulated material. So these are the types of requirements that we're going to see in the UL standard 496 around these types of products. Now, if we look at 410.62, we already did. We had the lamp holders, where metal lamp holders attached to a flexible cord. The inlet shall be equipped with an insulated bushing. So we just saw that in the standard that a lot of this language is a part of the standard. So if you buy a listed product that is listed for a pendant type, then these UL requirements are going to be found in 410.62a. And you say, well, why would we do that? Why wouldn't we just say it shall be listed and we can remove all of this? Well, you could theoretically do that. The challenge there is if it's not required to be a listed product, then some of this information can be helpful to the AHJ. Adjustable luminaires shall be required. Adjusting aiming the installation shall not be required to be equipped with attachment plugs. So these are your code sections that I would reference, 410.62, A, B, and C, which we already looked at. These are for your LED lightings, and we talked about 1, 2, and 3. And so here are some images, some of your, again, now the other thing that I'll point out on this, you have a strain relief right in here. That is basically taking the pressure off of the cord. The cord that's supplying power to the light fixture is not also suspending that light fixture. Now, it almost may look like it is here, but there is a separate cord that is being used in that case to suspend the light, and then the power is being routed to that light. Right, so in this case here, we've got a cord and plug connected, but this base unit is what's mounted to the ceiling and is what is suspending it. And we've all seen these before, right? So if we take a look close up, this chain is what's providing the support, and then the power for the light is intermixed inside of that. And I love this one. Look at that. I would say that's ungood. But in any case, you'll find a lot of things with lighting. Now, in this case here, this is a pendant style light because this cord is supplying power to that light and it is supporting that light. And it'll be listed and tested as such. All right. And let's see if we have any comments on my tube land. Cord connected does not equal cord and plug connected. That is true, Mr. Brian Rock. Listed as a lamp holder or luminaire versus portable lamp, cord and plug connected. Those are two separate things. Brian's noting also the particular UL guide information and CSA product class info identifies generally how any given UL product category or CSA class is suitable for specific types of applications. Absolutely right. So good input, Brian. Thanks for that. Thanks for that input. Okay, we're going to go to 17 now. Before I go to 17, I'm just going to take a look at my Facebookers out there. All right, so let's go to 17. We're going to have some fun now on 17. Are all luminaires suitable as raceways? If not, how will designers, installers, and AHJs know the limitations of the specific luminaire? Okay, so if we look at 410.21, which I'm going to go back to my code book, 410.21, temperature limit of conductors in outlet boxes. Luminaires shall be of such construction or installed so that the conductors in outlet boxes shall not be subjected to temperatures greater than that for which the conductors are rated. Branch circuit wiring other than 2-wire or multi-wire branch circuits supplying power to luminaires connected together shall not be passed through an outlet box that is an integral part of a luminaire unless the luminaire is identified for through wiring. And then they have for a reference to 410.64. So, and 410.64 is saying that luminaires shall not be used as raceway for circuit conductors unless they comply with A, B, or C, listed, and then through wiring, identified for through wiring. Luminaires listed and marked for use as a raceway shall be permitted to be used as a raceway. So when you're looking at, a lot of these types of applications, we like to use the body of that luminaire to run wires to the next light or possibly to something else, right? But if it's not listed that way, then you can't use it in that manner. So these types of lights, and I've done it myself, where you pull that wire and use it as a raceway to get to the other side, right, and provide protection. All right, let's take a look at the questions now. Nothing out there on. Let's take a look on tube land. All right, so let's move on to question number 18. Are luminaires suitable for use on circuits of multiple voltage levels? Are voltage limits typically assigned to luminaires? If not, how will designers, installers, and AHJs know the limitations of the specific luminaire? Good question. Are luminaires suitable for use on circuits? So it depends. You could get products that are multiple voltages or listed as multiple voltages. And I might have, just going to take a look. Control F, voltage. I'm doing a quick look in the, I'll just share that with you. I'm in the marking guide from UL. And see what they put in here for voltage ratings. All right, so voltage is greater than, not for use in dwelling units. So voltage other than 120 volt, incandescent luminaire designed for connection to other than a 120 volt supply is marked with its input voltage. So that's an interesting part. So if you have an incandescent luminaire designed for connection to 120 volts, it may not need to have its voltage marked. A luminaire that employs a device that is designed to operate only at a specified voltage is marked with its input voltage. So we know voltage is critical on most things that we install. So, and I'm back up at the top. So there's nothing in the marking guide with regard to that luminaire. So let's take a look. A luminaire is a complete lighting unit consisting of a lighting source. So we already know the definition based on our last discussion of our last video, our part 1 for this series. We talked about the definition of a luminaire. It's a complete lighting unit consisting of a light source, such as a lamp or lamps together. And then some luminaires are listed for both 120 and 277, and those can be used at both voltage levels. They're not like a slash and straight rated breakers that we have from a voltage from a breaker perspective, and again impacts the light intensity or other requirements of the luminaire. So this is a ballast, a fluorescent lamp ballast that's listed for both 120 and 277. And you can see that, make that a little bit bigger for you, right over here. So that, whoops, I'm sorry, right over here. So that shows you that, and it shows you for the different types of lamps, you're at 120 volts, how much current it will draw, and then at 277 volts, how much current it will draw. So some of these ballasts can be applied at both of those voltages. And you look at this is a 100 watt metal halide ballast that can be applied at 120, 277 voltage, either one of those voltages. So my only note in this regard would be that you have to understand the ratings of the equipment that you are purchasing and that you're buying, because obviously it makes a difference that some lighting can be used at only one voltage, or it can be used at different voltages, but you'd have to follow, when you specify the lighting, you're going to want to use the catalog information from the lighting manufacturer to select the right lighting fixtures, if that is a desire. The only thing I would say is that when you have a voltage rated at two different voltages, then it's a more flexible lighting fixture that you can use in multiple locations within your design. So It's like buying a 600 volt rated overcurrent device as opposed to a individual devices that are rated 120, 240, 480, etc. If you just bought it 600 volt rated, then you can apply it in much more locations than just a 120 straight rated device. So, so you would rely on the manufacturer's specifications and catalogs as you're picking the lighting fixture or the luminaire. All right. See if I had any questions in on this one. Nothing on YouTube. Let's take a look on Facebook. And no comments on Facebook. Okay, this is good. Let's move into question number 19. Is integral thermal protection required for all types of luminaires? No. Integral thermal protection is not required for all types of luminaires. And remember, you got to remember what the definition of a luminaire is. It's, includes that whole unit. Let's see, I do have a diagram in here. So UL 1598 shows where a typical protector appears electrically in an HID luminaire. So you'll see where the thermal protector is from a circuit perspective. So self-heating thermal protectors, more commonly called SHTP. It almost reminds me of saying shut up, doesn't it? But SHTP are devices used in recessed lighting luminaires that sense overheating of the luminaire and then obviously shut it off, right? So if we look back at that diagram, you'll have your thermal protector built in to the luminaire itself. And the SHTP consists of a resistive heating element, a bimetal switch, and some leads, all typically packaged in a small enclosure. So everything is self-contained, and basically it integrates and it's in series with the lamp circuit and opens that circuit if too much heat is detected. So it'll limit itself. Again, it's not required for every luminaire to have that. If that is something that you desire, that's something that's in your design, you're going to have to make sure again that the luminaire you're purchasing has that capability. They're required to be provided per 8.5 of UL 1598 in incandescent, high-intensity discharge, and fluorescent luminaires that are recessed. So if you buy that type of light, and it's a UL listed 1598, if you buy an incandescent, an HID, or a fluorescent recessed type, it is required to be in that circuit. So it will depend upon the technology on whether or not you are provided with that type of protection. Alrighty then. And let's take a look back at that question, make sure I answered. Is integral thermal protection required for all types of luminaires? And the answer to that is no, it is not. It is required per the standard for HID, fluorescent, and incandescent. All right, now we're going to move into our question number 20. We're 5 away, so we got 25 questions. Let's see if we can get this done in the next 20 minutes. Is lamp containment required for all luminaires? Lamp containment. So a lamp containment I would say no. Remember, there are the requirements that we already talked about in closed closets and in sporting event and gyms types of perspective. And then you also, you have your hazardous location areas as well. And so in some areas, in light and high intensity discharge luminaires, metal halide, luminaires that use a metal halide lamp other than a thick glass parabolic reflector lamp shall be provided with a containment barrier that encloses the lamp and shall be provided with a physical means that only allows the use of a lamp that is type O. And they reference the standard. In 410.16 again, we're going back to 410.16, what's permitted Only luminaires of the following type shall be permitted in a closet. And it talks about those that have the for storage space. So surface mounted recessed incandescents with a completely enclosed light source. So again, when you get into whether or not it's an enclosed light source or not, let's go back to the question real quick. Is lamp containment required for all luminaires? And it's not required for all luminaires, but I guess the message is, if it depends on where you're applying it, right? The location that it's being applied. If it's in a hazardous location, obviously there are going to be containment issues. If it's in that sporting arena, which is a previous question, there are containment items. If you're in an area where you are you're near fabric or other ignitable sources or materials, then you're going to have some containment and spacing requirements. So it's not required on everything, but you have to understand the location and its application as based on the NEC. And I would review a few of the earlier questions on locations like in the gyms and our sports arenas and in closets, closed closets, those discussions from the previous questions to help understand the answer to this question. All right. Let's take a look at the next question now. All right, we're going into 21. Is a disconnecting means required for all luminaires? Good question. So you have, you will have some sort of a disconnect due to just the overcurrent protective device upstream. So what it really comes in, whenever you think about a disconnecting means, in general applications, I guess you have those requirements, you have those questions of whether or not you need it next to the equipment. Like you have disconnecting means for generators, you have disconnecting means for motors, and you have disconnecting means in photovoltaic systems. And there are applications that will drive where that disconnecting means needs to be located for that luminaire. You have a form of disconnect based upon the overcurrent protective device in the branch circuit that'll be turning off that branch circuit that's supplying power to that luminaire. Indoor fluorescent luminaires that use double-ended lamps and contain ballast that can be serviced in place must have a disconnecting means. That's in 410.130G. So if I look at 410.130G, disconnecting means in indoor locations other than dwellings and associated accessory fluorescent luminaires that utilize double-ended lamps and contain ballast that can be serviced in place shall have a disconnecting means either internal or external to each luminaire. For existing installed luminaires without disconnecting means that at the time a ballast is replaced, the disconnecting means shall be installed. Now, I believe to serve this code requirement, the connector that's inside those is listed as a disconnect, so you should be able to, if you use the right connector inside of these ballasts or inside of these lighting luminaires, those are listed as a disconnect. You don't need to put a little switch on the outside of that or whatnot. Now, I do know too, back in 210, to get us out of 410 a little bit, from a lighting perspective, I think in 210, 70 something, we have the requirements for a lighting disconnect, like when you are on a landing or when you're at the top of the stairs and at the bottom of the stairs, right? You'll have a light that could be controlled by both of those areas. And we just made a change for adding a light switch to switch lights on when you come into an area. I'm just going to look for it here real quick. Additional locations. So lighting outlets required, habitable rooms, lighting outlets, all occupancies. So this is your lighting outlets for habitable rooms, additional locations, guest rooms and guest suites, all occupancies. meeting rooms, other electrical equipment, HVAC, showroom windows, guest rooms and guest suites, basements. I'm just looking for 21052. Those are receptacle outlets. 21052. I got to get out of 21052. Those are your required outlets. Branch circuits 210.25 requiring branch circuit requirements. And common areas. Boy, where is that requirement? Household ranges. Branch circuit ratings and conductors, reconditioned equipment. Maybe it's 210.11. Circuits, a number of load proportional to dwelling units, small appliance, laundry, bathroom circuits, garage. That's 210.11. Crawl space lighting outlets, 210.8. Branch circuit voltage limitations. We already talked about all of that. I'm looking for grouping, line to neutral, disconnect. Each multi-wire branch circuit. So that's your multi-wire branch circuits. I don't know where I did with it. Anyway, you have requirements for controlling your lights at the top of the stairs, at the bottom of the stairs. So there are different types of, not necessarily a disconnecting means, or just control means for controlling your light switches and things of that nature. So in any case, what else? Okay, let's take a look on YouTube. Cord connected, so we don't have anything else on YouTube. All right. Let's move over and do number 22. All right, so where luminaires are provided in sections with remote parts, are the interconnecting circuits provided as part of the assembly, or does that wiring simply comply with the branch circuit limits in Article 210 and a wiring method from Chapter 3? So where luminaires are provided in sections with remote parts. So you have a luminaire that has remote parts, so like the interconnected. So you may have a luminaire that I guess you would say, you could have various, that pendant luminaire that has the pendants with the wires that are the pendant, that could be listed as a luminaire, right? And that has different parts. So I guess this question is looking at, are those connecting wires and circuits, is that a part of the listing, or do you have to follow 210 for branch circuits and then do the ampacity and whatnot based on Chapter 3? So under cabinet lighting is a good example. Each section and the connected parts are a part of the fixture governed by the listing. So it's all part of the listing. And in most of these cases, otherwise, you could obviously daisy chain lights with each other. And if you're doing that, if you're taking a circuit, feeding one light, and then feeding another light, those interconnected are not listed as one unit. The wire that's in between would follow 210 wiring practices in Chapter 3 sizing, etc. But if you're dealing with lighting like this, then this is all a part of an assembly that's listed. So this connection point, and you can see how the fixture has specific terminal and plug connectors on either end so that you can install them correctly. That would all be a part of the listing. This is a puck, so to speak, and all of the wiring that's connected, that's all part of the luminaire and part of the listing. So this is a Halo product here, and that's your connection point. And there are listing requirements, and they are tested together to be daisy chain. This is sort of what that connector looks like, and the cord and plug connected on the one side. So all of that is a part of the listing. So I would say, to answer this question, where luminaires are provided in sections with remote parts, I would say it could be both, right? It could be that they are all listed together, or it could be that they are not listed together and you are daisy chaining lights by feeding them through and the wiring in between each of those lights is governed by Chapter 2 and Chapter 3, wiring methods and protection in the National Electrical Code. And you're going to have to size the conductors correctly, protect the conductors correctly, etc. So I would make that argument that it could be either way, but to point out these types of applications here, these are all part of listed luminaires. If they're all part of the listing, the wiring methods that are used are all basically based upon the listing, and as long as you are applying that product within its listing, then you are good. All right, let's go to question number 23. We only got 3 more to go. 23, 24, 25, 3 more. So light levels do not appear to be regulated by the NEC. What standards determine the amount of light required for specific tasks? Another good question. I would go back to your building codes. They have specific lighting or safety requirements. Kitchen, task lighting, egress, stairwell illumination, etc. All of those are part of your safety codes and other building codes. Your International Illumination Society, your IES standards will give you guidance on that. Your healthcare codes, NFPA Doc 99, other documents may have requirements for additional illumination requirements. So look at your healthcare codes and standards. And your health department may have requirements for the food preparation area, or for those areas where that you're going to have food. And some of, like, I know freezers and things like that will have special lighting requirements that are lighting food. So all of that, the NEC may not have it, but you can go to the IES standards, healthcare codes and standards. Don't forget about the healthcare or any other really specific. You may be in a specific application that is not covered. It's not a healthcare installation. It's not something that I'm thinking of right now. It might be a unique application where there are codes and standards around that application that may have specific requirements. But they will be outside of the National Electrical Code, because the National Electrical Code, remember, is an installation requirement. Question number 24, where specific levels of light are required, how can that level of light be determined? Are lighting levels measured the same for all types of luminaires? You've got to call the light busters, right? So you've got to find somebody who understands lighting measurements, and they will bring the proper tools in to get that done for you. So where specific levels of light are required, you're going to use specific meters to give you your lighting measurements in those environments. And your electrical inspectors or your inspectors for the life safety codes, etc., will be using these types of equipment to determine and detect your lighting levels. There's a myriad, just like we have voltage meters and current meters, etc. There are a lot of meters that are out there. You have to understand the tools that you're using, and you have to understand the proper measurements. Different lights will emit different lighting fixtures, different type of bulbs, and technology will offer different levels of lighting coverage for you. Different fixtures will offer different levels of lighting coverage, and you have to understand the codes and standards that you're trying to enforce to be able to measure things correctly. And fortunately or unfortunately, you're going to need to know the how to use the equipment as well. All right, so our last question, and it's 154, retrofits. Can I retrofit existing fixtures with new updated guts to reduce energy? I want to use these new LED lights. Any problem with that? Okay, well, there are retrofit kits that you can use for to update the existing fixtures. 410.16, let's take a look at 410.16. So we go back to chapter 4, and we go to 410. And we're going to look at 410.16, listing 410.6, 410.6. Listing required. All luminaires, lamp holders, and retrofit kits shall be listed. So, to our earlier point, some of the requirements that we see in the National Electrical Code reflect what's in the standard. as long as you're buying a listed luminaire, the correct markings will be there, etc. You have to make sure that you apply them in the right locations. So 410.6 says that all luminaires, lamp holders, and retrofit kits need to be listed. And then obviously you need to follow the listing marking requirements. So, here's an example of one of these types of fixtures. Now, I will say that, you look at the back of that unit. It's kind of beefy. You could see the fins right here. Those fins are associated with removal of the heat. From an LED lighting perspective, the deterioration of the life of the LED has to do with a function of the amount of heat that it's being subjected to. So to get the heat out, for perspectives, to get the heat out, we need to be able to leverage those fins on the back of that luminaire. Okay, these are all LEDs, and if we're retrofitting, you'll notice that there are heat sinks involved with the proper application of those products. In 110.19, lighting and power from railway conductors, circuits for lighting and power shall not be connected to any system that contains trolley wires with a ground return. Again, circuit connections. So there are specific requirements in Part 2, 110 space about electrical equipment. Illumination shall be provided for all workspaces about service equipment, switchboards, switchgear, panel boards shall not be, so control by automatic means shall not be permitted. Additional lighting outlets shall not be required where the workspace is illuminated. We may be replacing those with LEDs. Illumination shall be provided for all workspace. 210.6, this talks about the 277 volt lighting listing. So we have to apply these products based upon their application. So you've got 110.34 workspace and work guarding. You got 110.26 space about, illumination should be provided for all working spaces, about service equipment, switchboard, switchgear, controlled by automatic means is not permitted. So just keep these things in mind as we retrofit technologies into existing locations, that you're going to make sure that they're not controllable and they're not automatically turned off in any way, shape, or form. Branch circuit voltage limitations. Make sure you're applying them within their listing marks. Are connected to a branch circuit supplying 2 or more receptacle or outlets. Ratings shall conform to the values listed in Table 210.2. 21. Okay, luminaires, lamp holders, and lamps, low voltage lighting. All of these are various areas that you need to be concerned with. So, in regard to that question, retrofits can I retrofit existing fixtures with uploaded guts to reduce the energy? The uploaded guts, I would call those retrofit kits, and apply them within their listing and rating. So yes, you can do that. There shouldn't be any problem as long as it's a listed product and it's applied appropriately. And anytime we retrofit into an existing installation, we have to make sure that we are following all the rules of all those areas where lighting is required, where it's required to not be controllable or controlled by other sources. So refresh your memory on all of those applications as we retrofit these LED lights or and update fixtures from a futuristic perspective. All right, so that ends this program. That is the last question out of the 25. I did get other questions, which I will schedule another date and answer those questions. And let's see what that gives us. All right, so I appreciate everybody for signing in, and I'm going to bring this one to a close. Don't forget to please subscribe to my YouTube channel. Also, send me a friend request out on LinkedIn and on Facebook as well. Again, remember, I keep both of those pretty professional. On my LinkedIn site, you'll see my document for the lighting contacts. I will bring that up here in a second. I may already have it up. No, I don't. So if you go out to my LinkedIn site, I do have a a reference document that that I'm building out, and I will continue to grow those references that you may find of use for your applying lighting with regard to the National Electrical Code. Let me just bring that in up here and do 2 with me, actually. So if you go out to my lighting, just go to my profile, and so there's my profile. And you'll see it right here where it says going live today. That's going live today. Here it is right here. So a lighting reference list. And I'm going to continue to build this lighting reference list out. So you have that. So I have the general listing reference information. I have the applications. I have power factor, lighting, and the NEC. I've got LED lighting as well. So these are all of my references so far. I will continue to build this one out and bring that and keep that updated. So remember to bookmark that and keep checking back for it. But if you're following me on LinkedIn, every time I update that, I will send out a new version. So thank you for dialing in. We're going to end both the YouTube and Facebook at this point. So I appreciate, and this will be out there for future viewing for all of you on my YouTube site. Alrighty. So thank you very much. And I'm going to close down the program. So take care. God bless. Stay safe, and please stay healthy.